Okay, today's video is 2-5A, rational functions. So we are only covering the analyzing and graphing of rational functions, and I'm gearing it towards your homework in Delta Math. So hopefully that'll be a lot easier for you when you actually do it. So just keep that in mind. Okay, so to start off with, a rational function, f of x, is the quotient of two polynomial functions, a of x and b of x, where b of x is non-zero. So this is what it looks like. This is a rational function. So it's a fancy fraction that's going to have variables in it. That's the deal. Okay. Now, a couple of years ago, I had a class when I had to teach this, actually quite a few years ago. My class came up with a little mnemonic device to help us remember, and it was called Dr. IVH, and that's how we're going to remember what the steps are of graphing and analyzing these. Now, if you had to do it all by yourself from start to finish, and I told you just to graph one, these steps would really help you. You actually won't have to memorize them because it's all going to be asked of you, but you have to know what it means when you're told to do so. Okay, so for example, the D stands for domain, and when you're trying to find the domain of a rational function, okay, remember that's a fraction, and we've talked about in math, the only problems we have with domain are when we have a radical or a fraction. Well, here we have a fraction, so we have to know to set the denominator equal to 0 and solve. And what we're going to do, I've decided to answer the questions the way you would answer them in Delta Math. So when we go through the problems, you'll see that we're writing it a little bit differently, not using interval notation. Okay? All right, the next thing that you always want to do to answer the rest of the questions, okay? So all of these you're going to do after you do this step. And that step is you want to reduce it, okay? And you reduce it by factoring, and you're going to cancel out any common factors that you have on the top and the bottom. If you have a common factor on the top and the bottom, you're actually going to have a hole in your graph. So you will see that as we go through. Okay, you've seen holes on graphs in the previous chapter, but now we're going to actually figure out where they come from or how we know they're there. The I stands for intercepts. You have a y-intercept and an x-intercept. Okay, the y-intercept you're going to find by plugging in 0 for x. All right, the x-intercept, you can plug in 0 for y, the same thing, but it's easiest if you just remember to set the numerator equal to 0. Okay, and again, you're going to see it as I go along. I'm going to do lots of examples for you. Okay, the V stands for vertical asymptotes. To find the vertical asymptotes, you're again going to set the denominator equal to 0 and solve, but this time you're not using the one at the beginning, you're using this one. So if it ever reduces, you only have an asymptote if you still have something left in the denominator after you reduce the expression. Okay, keep in mind that you can always have more than one vertical asymptote. Okay, now the H stands for horizontal asymptotes. Okay, and to find the horizontal asymptotes, I know you did this in Algebra 2, you're going to look at the degree of the numerator and the denominator. So hopefully you learned something last year called Betsy, Bobo, and Botu. Most people remember that, don't necessarily know what it means, but I'm going to refresh your memory. Okay, so Betsy stands for bottom equals the top. And what we're talking about is the degree. So you're going to see it because I'm going to remind you as we go through, but I'm looking at the degree of the numerator and the degree of the denominator. Remember, the degree is equal to the highest exponent. So if the bottom equals the top, the C stands for coefficients. And if you remember back when I first started talking about polynomials, the leading coefficient was denoted by the letter A. So that's how I'm writing it. Okay, so this says that your horizontal asymptote will be y equals a sub n over a sub d. So a is my leading coefficient, n is of the numerator, and then down here is the leading coefficient of the denominator. And again, you'll see as we go through because I'll do some. All right, Bobo. Bobo stands for bigger on bottom. And if it's bigger on bottom, the O is really standing for the 0 because your horizontal asymptote is always y equals 0. Botu, bigger on top. The U, I didn't come up with this, somebody else did, and I was told it was stood for undefined, but it doesn't mean my horizontal asymptote is undefined. It really means that there is no horizontal asymptote, okay? And before I talk, well, I'll say it right now, okay? BO2, okay? What you're doing, okay, if the degree of the numerator is one, is one more than the degree of the denominator, then your graph will have a slant or oblique asymptote. And you're going to find that by using long division, which is what we did earlier in the chapter, okay? So one last thing before we go do some examples. Vertical asymptotes, you can have more than one, but a horizontal asymptote, you will have one or none. So you can't have more than one when you do that. Okay, so let's go look at these problems. 1 second, please. Okay, so look at the examples that we have here. First off, it says find the domain of each function and the equations of the vertical or horizontal asymptotes, if any. So the order's a little bit different about what you're going to do. So just follow directions, but I'm doing it as if you had to do the whole thing at once, which is what happens at the end of your homework, okay? So first off, I have to find the domain. So to find the domain, okay, remember, what did we just talk about up top here? The domain says set the denominator equal to 0. All right, in which case we're going to look for where the function is undefined. And that's what I'm saying, we're not writing in an interval notation. So I'm setting the denominator equal to 0, x minus 4. What makes that equal to 0 is 4. So my domain is all real numbers except x cannot be 4, because if I plugged 4 into this expression, I would have 0 there, and I can't have that. Okay? Next, excuse me. Next, find the equations of the vertical and horizontal asymptotes, if any. So remember, on our little mnemonic device, it's Dr. IVH. So the R stands for reduce. So you always want to try to reduce it before you find vertical and horizontal asymptotes. Okay? So my vertical asymptote is, if I have something left in the denominator, whatever is left in the denominator, I'm going to set it equal to 0. So I didn't have anything that cancels. So this right here, if it is undefined or not allowed in my domain here, that's what this is right here. Well, when it's equal to, that's going to be my vertical asymptote. So these are often tied together. The only reason they wouldn't be the same is if you have a hole. And the only reason you're going to have a hole is if you reduce. Well, this doesn't reduce because this factors to x plus 4 times x plus 5. That's not going to cancel with anything. So it does not reduce. Okay? Next, I have to find the horizontal asymptote. And the horizontal asymptote is what I just talked about, Betsy, Bobo, or Bo2. So I'm looking at the degree. All right? So I look at what is the degree of my top is 2. And what's the degree of my bottom is 1. So this is bigger on top, or BO2, and that means that I have no horizontal asymptote. Okay? It didn't ask me to find all the asymptotes. It just asked me to find vertical and horizontal. If it asked me to find all of them, then I would continue with the long division. Okay? All right, look at number 8. G of x equals x minus 4 times x plus 2 over x plus 1 over x minus 3. Okay, my domain, what's on the bottom? Okay, so what makes that 0 is negative 1. What makes this 0 is 3. So my domain is all real numbers except x cannot be negative 1 or 3. Okay, I try to reduce it. There are no common factors on the top and the bottom. So my vertical asymptote is what's left in the denominator. Well, that's everything. So it's going to be x equal to those things. So x equals negative 1 or 3. My horizontal asymptote, I have to go find the degree. Okay, so what I'm looking at is, you look at the first terms, y'all. This would be x times x, which is x squared. On the bottom, I would have x times x, which is x squared. And x squared over x squared means bottom equals top. So this is Betsy. Okay? And if it's Betsy, then I'm going to multiply those together, the coefficients. The coefficient here is 1. The coefficient here is 1. Coefficient here is 1 and 1. So I have 1's on the top, 1's on the bottom. 1 over 1 equals 1. So my horizontal asymptote is just y equals 1. Okay? So that was just a little warm up. Now we're going to actually go do some problems, full-fledged problems. So this is what I did to kind of help you through what's going to happen on Delta Math. So look at this first one. I'm going to go through all the steps. So the domain, remember I'm setting the bottom equal to 0. I have g of x equals 2x plus 3 times x minus 6 over x plus 2 times x minus 1. Domain, what makes this undefined is going to be -2 and +1. So my domain is all real numbers. X cannot equal -2 or 1. Okay, these are the numbers. -2 and 1 are the numbers that make this undefined. So just pay attention to that depending on the question. Okay, reduce. Do I have any common factors on the top and the bottom? I do not. So if I have no common factors, that means I have no holes in my graph. Okay, next I have, we'll come down a little bit. There we go. Next I have intercepts. Okay, so to remind you to plug in to find my intercepts, one, I'm going to plug in x equal to 0. And this is not so bad, but what happens, so that means everywhere I have an x, y'all, is a 0. So basically on top I have 3 times -6, and on bottom I have 2 times -1. Because what's left here when you put a 0 there is just 3. What's left here is -6. Okay? So when you simplify that, you of course get 9. So that makes that intercept 0, 9. I plugged in 0 for x, so 0 is my x coordinate. Okay? Now to find that's my y-intercept. Y-intercept, plug in x equal to 0. X-intercept, plug in y equal to 0. If y is 0, this has to be 0. So I'm setting my numerator equal to 0. They've already factored and done the hard work for you. Okay, so all I have to do is go look at this and say, what makes this 0? Well, I subtract 3 and divide by 2. So I'm going to have -3/2. And then I'm going to set this one equal to 0. I'm going to add 6. So I'm going to have 6, 0. Now, pay attention here, y'all. I got this wrong, just so you'd like to know, in Delta Math, because when he asks for the x and y intercepts, you have to put them as coordinates. Okay? So make sure that you make sure that one of your numbers is 0 if it's an intercept. Okay? Before, when you've done problems before and he's asked you for the y-intercept, all you do is type 9. You can't get away with that now. But one of the other things I wanted to point out now is for you to see 0, 9 is my y-intercept. 0, 9 is right here on my graph. -3/2 0 is my x-intercept. It's right there. 6, 0 is right here. So when you do this in Delta Math, he's going to ask you to go find these things, and you're going to go plot them. And then when you finish, you click on the button that says plot the rational function. And if you've done it correctly, then it will be graphed through all of your information. Okay? Vertical asymptote at, where's my vertical? My vertical asymptote is where this is, where my denominator, what's left in my denominator. Same thing. If I don't have any holes, y'all, it's this with an equal sign. So that means I have a vertical asymptote at x equal to -2 and x equal to 1. Now, I'm not going to draw these asymptotes very well, but I'm going to point out this right here. Let me do it to match. This right here is x equals -2. This right there. So if you were to follow that all the way up, you can see that this guy's going up and this guy's going down, and nothing's going to cross that. And the other one is at x equals 1, which is right here, x equals 1, and that looks like it's approaching it as well. So in Delta Math, when you do it, you click on vertical asymptote, and then you get it and you drag it over to the right place. So you'll see, it's kind of nice. I like it. Okay, horizontal asymptote. We look at the degree. Okay, so you can count up your x's. You can multiply 2x times x is 2x squared. X times x is x squared. So I have an x squared over an x squared, which means bottom equals top. It's Betsy. Okay, so you're multiplying all the coefficients together. the leading so that's going to be 2 times 1 over 1 times 1, and that simplifies to y equals 2. So my horizontal asymptote is right here, y equals 2, if I were to put a dotted line. Okay, and I can draw this a lot better than I can draw those vertical ones. That's why I'm not torturing you. But I want to point out, so this guy it would be approaching that, and this guy would be approaching. Okay, you can cross a horizontal asymptote. This graph crosses the horizontal asymptote. You may never cross a vertical asymptote. So you'll see that when you're doing the graph. So let's go do some more. So this will be very easy for you. All right. Now I have f of x equals x times x plus 6 squared times x minus 4 over x squared minus 5x minus 24. Okay, to find the domain, I'm going to have to factor this. Okay, so to factor it, I've got x and x, and I'm looking for the factors of 24 that subtract to give me 5. Factors of 24 that subtract to give me 5. So I'm sure you already know it's going to be minus 8 and plus 3. So my domain is going to be all real numbers except 8 and negative 3. Okay, can I reduce? None of these factors show up here, so I cannot reduce anything. So I have no holes in my graph. Intercepts, okay? So when you plug in 0 for x, okay, on the top, well, that's a 0. And if that's a 0, the whole thing is going to be 0. So I've got 0 on the top. And when I plug in 0 down here, everywhere you see an x is a 0. So that's gone. That's gone. So I'm left with just negative 24. So 0 divided by negative 24 is 0. So when I plug in 0 for x, I get 0 for y. So that's one of my intercepts. Okay. The other ones, remember, is I'm going to set each of these equal to 0. So we already set this one equal to 0 because that's right here. If I set this equal to 0, x plus 6, that's going to give me negative 6, 0. And if I set x minus 4, I'm going to get 4, 0. So do these match? I've got 0, 0. I've got negative 6, 0. And I have 4, 0. So again, you'll have to plot those in Delta Math. Okay? Vertical asymptotes. I have no holes, so it's the same thing as my domain. X equals 8 or negative 3. Okay, so I'm going to write that up top. So where's negative 1, 2, 3? This right here is x equals negative 3. And over here is x equals 8. Okay, so I've got vertical asymptotes in both of these places. And you can see that the graphs are actually approaching it, not crossing that. Okay, then I have horizontal asymptote. So that means that I'm looking at the degree of the top. So I have 1x right here. I have 2 right here, because that's in squared. And then I have another one here. So 1 plus 2 plus 1 is 4 on top and 2 on the bottom. So that is bigger on top, which is undefined. And that means I have no horizontal asymptote. If this was, remember, this was 4 and that was 2. If the difference was 1, then I would have a slant asymptote and I would have to go further. Okay? And I will tell y'all that there is another piece of this graph. I went ahead and plugged in 9 if you're trying to figure out what it is. If you plug 9 into this expression, you get like 33,000. So it's way up here off the graph and not important to it, but I just wanted you to know it was there in case anybody thought the graph was wrong. So FYI. All right, another one looking a little different. Notice how each of these graphs looks different, y'all. So that's just something to keep in mind as you're going through. Okay, sorry about the cat meowing. I'll be with him in just a minute. Okay, h of x equals 3x minus 4 over x cubed. So my domain is my denominator. Where is it equal to 0? Well, at 0. So all real numbers except x can't be 0. There are no factors to cancel, so there are no holes. My intercepts. Well, I don't have a y-intercept because if I plugged in x equal to 0, wait, my domain said x can't be 0. So that means it doesn't ever cross the y-axis. if I make the top, so the other one is to set the top, set this equal to 0. And if I set that equal to 0, I'm going to add 4 and divide by 3. So that gives me 4/3, 0. So where is 4/3? Well, it's right there. So we're good. So you would plot that point. Okay. This is x equal to 0. All right. So my vertical asymptote when I have no holes is the same thing as my domain, but it's equal to. Okay, so if I wanted to, sometimes, especially when it's on the axis, I actually label it because it makes it easier to see. It's hard to draw on top of the axis. And the horizontal asymptote, it is degree of 1 here, a degree of 3 here. So it means it's bigger on bottom or bobo. Bigger on bottom, that O means y equals 0 is our asymptote. So my other asymptote I have would be here. And again, sometimes it's hard to see, and again, I told you, it can cross a horizontal asymptote. It can never cross a vertical asymptote. So just keep that in mind. Okay, I think I just have 2 more examples, y'all, and then we're done. Okay, we looked at this one earlier. All right, this is f of x equals x squared plus 6x plus 9 equals 20 over x minus 4. Okay, we already know the domain doesn't factor because we tried that. So my domain was all reals, x not equal to 4. It does not reduce, so I don't have any holes. My intercepts, okay, if I plug in 0 on the top, I'm going to get 20. If I plug 0 in the bottom, I'm going to get -4. So 0 for x and -5 for y is my y-intercept. Okay, I'm going to go plot 0, -5. Okay, that's 10. Okay, this is 10, and that means it goes by 2s. And it had to go by 2s, y'all, because if I did this graph here by 10 by 10, which is what I normally do for y'all, you wouldn't see this piece of the graph. So that's why I put it on there in so big. So that right there actually is -5 because it's halfway between 0 and -10. Okay, to put the numerator equal to 0, remember I talked about factoring that up at the top. This is x plus 5 and x plus 4. So that makes my x-intercepts at -5 and -4. So they are right close to each other, which would be one would be right there and one would be right there. You can't see it unless you zoom in, but it does match my graph. Okay, vertical asymptote. Same as domain if I have no holes, but equal to. So x equals 4. Where's x equal 4 on my graph? That's right here. It's that one. X equals 4. Okay, so you can see it more when you follow down this way, that this part of my graph is approaching x equal to 4. That part is approaching x equal to 4. My horizontal asymptote, what is the degree of the top? It's 2. What's the degree of the bottom? It's 1. So this is bow2, which means I don't have a horizontal asymptote, but my numerator is 1 more than the denominator. So that means I have a slant asymptote. And how do I find that slant asymptote? Is I'm going to have to use long division. So I'm going to divide x minus 4 into x squared plus 9x plus 20. So what do I multiply x by to get x squared? Okay, or x squared divided by x is x. I didn't want to write the whole thing. Anyway, so x times x minus 4 is x squared minus 4x. When I subtract, 9 minus -4 is 13x, and I bring down my plus 20. What I multiply x by to get 13x is 13. Well, the nice thing about these problems, y'all, is this is all that we care about. We don't care about the remainder. So my slant asymptote is y equals that quotient. Y equals x plus 13. So if I were to graph it, I will tell you that 13, this is 10, 12, 13 is like right here. That's -13. That's positive 13. It's a positive slope. So the line would go like this if I was good and could draw diagonally, and I can't. So that's what your horizontal asymptote looks like, but you can see the graph approaching it. So that's what it looks like. Okay, last one. Number 28. So f of x equals x plus 4 over, no, x plus 4 times x minus 1 over x minus 1 times x plus 3. So what's in my bottom? What makes this 0 is 1. What makes that 0 is negative 3. So my domain is all real numbers. X can't be 1 or negative 3. Can I reduce this? Aha! I have a common factor on the top and the bottom, so they go away. And if they go away, what am I left with? I am left with x plus 4 over x plus 3. That is what I'm going to use to answer the rest of the problems. Makes your life a lot easier. But because I had a factor that cancels, I now have a hole. Where do I have that hole? Well, the factor that cancels was x minus 1, so I'm going to set it equal to 0 and solve it for x. And so x equals 1 is where the hole is, and to find the other part of the hole, I'm going to plug it in right here. Don't plug it in here. If you plug it in there, you're going to get 0 over 0. So you plug it into this thing. 1 plus 4 is 5. 1 plus 3 is 4. So my hole is at 1 5/4. So if I go to 1 5/4, that's right here. So if you were drawing it by hand, you would draw an open circle. When you do it in Delta Math, it's going to be an open circle, and you're going to drag it to an approximate place of where that hole is. Okay, intercepts. Again, I'm using this one that's highlighted in green. So what I'm doing is plugging in 0 for x. If I plug in 0 for x, I get 4/3. If I plug in 0 for y, that means I put the top equal to 0, and that's going to be negative 4. So let's go see. 0 4/3, that's right there. And negative 4 0 is right there. So I'm good. Vertical asymptotes. Okay, so this is an example. We had a hole. So what's left in the denominator is this one. So this is not a vertical asymptote. Only that guy is. So my vertical asymptote is x equals negative 3, which is right here on my graph. I'm going to draw it. It's right there. Didn't mean to touch it, but x equals negative 3. If you can use your imagination, the nice dotted line is drawn there. Okay. And then horizontal asymptotes. What's the degree? Again, y'all, we're still using this one. The degree of the top is 1. The degree of the bottom is 1. So that means this is Betsy, because bottom equals top. So I'm going to use the coefficients. All right, what's the first? The top coefficient is 1. The bottom coefficient is 1. I didn't need both those. I just needed 1, y'all. And that gives me y equals 1. So my horizontal asymptote is y equals 1, which is right here on the graph, which I could draw if I wanted to, but I'm not going to do very well. So that's all she wrote. So I hope y'all thought that was pretty easy. I think the way that we have your homework set up in Delta Math makes this a lot easier than what we've done in the past. So hope you enjoyed that. If you have any questions, please don't hesitate to contact us, email us, and y'all have a great day. Thank you so much.